Before heading to the video, if you haven't subscribed the channel, do subscribe it and don't forget to click the bell icon for the latest update notification. If you like the video, do like, comment and share. Stay tuned with learnbay.co. Happy learning!
What is p-value or what is p-value approach? Okay, so your problem is like this. Okay, consider this as your question. Here is your mean. Then based on the confidence interval, let's say you have, although this is not a very good design, a certain range, okay? Now, basically the idea is very simple, that you will take a sample and now you will try to calculate, let's say, so if this is mu naught, you try to find where is the mu from the sample. Mu, let's call it mu s. If this falls within this range itself, or mostly in this range, then we basically got to accept mu naught as your default null hypothesis. Okay, what is null hypothesis?
No relation between two variables.
Sorry, can you repeat that?
No relation between two variables.
Anyone else? What is null hypothesis? Fundamentally, null hypothesis is kind of a default hypothesis or an assumption that you make about the system, some mathematical parameter of the system. So let's say you say mu naught is the time taken, okay, or this is the default mean, okay. Here, let's say I am taking time taken, but you can also try to understand it as like maybe it is some kind of a default value, default mean value of the system. Okay. Now the idea is, and then of course we have to ask the question immediately that what is the alternative hypothesis?
No assumption.
Yeah, basically you are making assumption that it might be wrong or there might be something different. And basically alternative hypothesis and null hypothesis are mathematically opposite. What does mathematically opposite means? Anyone, any idea what does mathematically opposite means? So it is like two statements which are, if one is true, the other won't be true. Okay, so what could be a good example of such?
Even and odd.
Even and odd. Good, good. Anything else?
Head and tail.
Sorry, I didn't exactly catch. What did you just say?
Head
Head
and
and tails. Okay, yes, yes. Head and tails could be one. Anything else? Even such statements like x is equal to greater than 5 and x is less than 5.
any mathematical representation of that?
Yes, but you have to be very clear.
Yeah.
Mathematical opposite means if this one is true, then if one is true, then other has to be false. Both can't be true at the same time. That's the idea of mathematical opposite. Okay. So in order to do correct hypothesis testing, Now the problem is very simple, that let me use this figure itself. So the idea is very simple, guys. If you really think about it, if this is where the boundary has been drawn, let's say this is one tail problem, okay? So the idea is from here onwards, anything bigger is okay. Let's say this is how your question is defined. So anything bigger is okay, but you cannot go lower than this. And this is your, let's say, assumption mu naught, okay? But based on the sample, this is the mu s, or this is the point you get, and you can call this mu s or new mean. So would you accept, okay, so would you accept the null hypothesis or would you reject the null hypothesis? In this case, even just by looking at the picture.
Reject.
Reject the null hypothesis. Very good. So how would you calculate, or how would you get the idea that it has to be rejected here? Or like what would be the mathematical formulation? Again, if you remember from that day, it is pretty simple.
Less than new
Yeah.
mean.
Yeah, even equal to, even just not less than, even less than equal to alpha. Okay, or basically p value is less than acceptance region. One has to reject the null hypothesis. Okay. And it will work, the same idea will work for one tail, upper or lower, or even two tail. Because again, remember, p value is an area, alpha value, acceptance region is again an area. So they can be either zero or positive, they can never ever be negative. Okay, so remember this point, and this is like of most critical point here. And similarly, you can see a similar example for the positive one as well. But maybe I can also take a critical value approach for, let's say, one tail or two tail hypothesis. Now this is okay. So now this is what I want to remember. P value is an area. Critical value is a point on real number line. So let's say I draw a real number line. So anything from your negative infinity till positive infinity, 0 would be somewhere in middle. All the points, all the values are considered. So from this area, it is all positive, and in this area, everything is negative. Agreed?
Yes.
Yeah.
Okay, cool. So basically, critical value approach is nothing. Basically, you get the z-score. Z-score is calculated as the simpler equation is you can use like mu minus mu naught by sigma by under root of m. Okay, this will give you the z-score. So we are literally asking, in one we were getting p value. P value is basically the probability value. Now probability value can be 0 or positive, or 0 maximum until 1. But z-score from this onwards, let's say if you were to make again a Gaussian, so now what we are asking is get the z alpha value and get the z mu value. Okay, now compare both of them. Okay, so there are two rejection rules here. What are these rejection rules? Can anyone think of them? Reject H naught when
Z mu is less than Z alpha.
but remember, both of them could be negative as well, and there the rule is just the opposite, right? If this is somehow negative Z alpha and this is your, let me use this color, then how would it work? Okay, tell me, which one is bigger, 5 or 9?
9.
Very good. Which one is bigger?
-5.
Very good. Now you have to remember the same thing here. Because once you get in negative domain, this is not how things work. Okay, this rule is not enough. In p-value, there is only one rule, right? For rejection, alpha should be.
So Z mu less than equal to Z alpha?
Sorry, what you were saying here?
Because in positive it is a greater than equal to, in negative it might be the less than equal to I mean Z of alpha.
You just have to take absolute value of these maybe.
Yeah.
Yeah, you can do that, or if you are not allowed, you will have to use the, or means you will have to use two rejection rules. So basically the idea is very simple. The value of test statistic that establishes the boundary of rejection region is called the critical value, basically the Z value, okay? And these are two rejection rules, okay? In lower tail, reject H naught if Z is less than equal to negative of Z alpha, and reject H naught if Z is greater than equal to Z alpha. I would like you to write both of these down right now.
Can you please switch back to the drawing that you had?
One sec.
Okay, thank you.
Okay. Please note down both of the rules. It would be really handy for you. Okay. So this is how it's gonna look like, okay? Okay, let's make sure we get it step by step, okay? Now, if you're doing through p-value, this is the approach. First three steps are actually common in both of them. P-value, critical value approach. Both of them will do the same trick. So basically, you have to develop the null and alternative hypothesis. What is the null hypothesis and what is the alternative hypothesis? It depends on question to question. There's no one set answer that you can always utilize and always get away with. No, you can't do that. It has to be determined through each question. Now you have to specify the level of significance alpha. Okay. How much, 0.2, 0.1, and is it a double tail, single tail? That also you have to know. Now you collect the sample data and compute the value of test statistic. Okay. So you basically get the mu s or something. Now p-value approach is very simple. Once you get the test statistics, you try to get the p-value. So you use that J chart and you try to get the exact probability value, okay, how much it is covering. And there's only one rule, reject H naught if p-value is less than equal to alpha. In critical value approach, step 1 to 3 are exact the same, only fourth and fifth change. So use level of significance to determine the critical value and rejection rule, and use the value of test statistics and rejection rule to determine whether to reject H naught. And just to remind you, these two are the rejection rules. Okay, so if you are ready, go ahead and solve this one. You guys can use your calculators to solve this one. How would you solve this? The idea is very simple. You have four random sample of 40 medical emergencies, okay? The sample mean is 13.25 minutes. The population standard deviation is believed to be 3.2 minutes. Now EMS director wants to perform a hypothesis test with a 0.05 level of significance to determine whether the service goal of 12 minutes or less is being achieved. Now, which kind of tail problem it is? Can anyone tell me?
Two tail.
Two tail, how?
Plus or minus.
No.
Single
How?
tail less
Yeah,
than or
yeah.
equal to 12 minutes.
Yeah, because look, this is the point you have to understand. By reading the question, you will have to make sure that you understand. So fundamental problem is what? That mu, whatever the mu is, should be less than equal to 12 minutes, or mu naught is basically this. This is what you are claiming. So mathematical opposite would be
Greater than 12.
okay. So by looking at this, do you think it's a two-tailed problem?
No.
It's a single tail. Actually, it's upper tail problem. It should not go beyond certain margin. That's the point. So how would you solve this one now? What are the first three steps? Can anyone remind me right now?
Hypothesis and alternative.
Exactly. First, develop the null and alternative hypothesis. Specify the level of significance alpha and calculate the sample data and compute the value of test statistics. Can you do the first three steps? Okay. So null, let's first develop the hypothesis. So this is your null hypothesis. This is the alternative hypothesis. Alpha is 0.05. It's a single tail problem. Okay. So how would you get the z value if we wanted to get? So as I just said, basically it's a simple idea. Whatever you have calculated, let's say the sample mean is 13.25 with the mu naught, that is 12. 3.2 is the standard def that has been given, and under root 40 means 40 is the sample. And if you do this calculation, you should get 2.47. Is everyone getting the same answer? Did you guys get the same answer?
Yes, Omkar.
Okay. Now, how to know what are the rules for rejection? So you can take a p-value approach. So what would be the p-value? Okay, so alpha is already the area. Alpha is 0.05. This is already an area. You don't have to convert into probability. It's already a probability. Okay. Now, now let me ask, what is the p-value here? P-value where z is 2.47. Sorry. How would you find the z value? Sorry, probability p-value, my bad. Again, you have to kind of go for these apps or online tables. So you just need to remember, you basically have to just get the z distribution tables. Okay, so just make sure that you find the correct one. And where's both of them? Actually, okay, we just need to find the positive one anyways. So let me see. I used to get that very first. Yeah. Okay, let's try this. I'm not finding the regular one which I used to use time and again. Yeah, I think I got it. Okay. So 2.47. How would you get the area? Come on, guys, fast.
99.31. Yes.
Careful, very careful.
Okay.
So what you want is, let's say this is your mu s. So the area is basically this. Now, what did you just see is, or what this table gives you is this area, right? So basically whatever you have to do, whatever area or whatever value you find from here, you have to do basically like this, 1 minus whatever value you got to get the p-value. In lower tail is not a problem, okay? Lower tail is correct. In the upper tail only, it basically becomes confusing for some people that basically, let's say this is your mu s. So its area is like this, right? From here onwards to the, because it's upper tail problem, remember. Anything going lower is fine. Actually, upper is the problem. More extreme is the issue. But now the area or the value that you get from here, let's say this one or something like this, tells you the value from negative infinity till that point. So how would you get the reverse area? By doing this 1 minus whatever the value you have got. Okay, makes sense? So we got like 2.47. So let me track this, 2.47. Okay. So 1 minus 9932. How much is this area?
0.0068.
Very good. So is it less than 0.05? Yes. So you realize p-value is less than alpha, which happens to be 0.05. So what is the conclusion here? We reject Is it clear? How did I just do this?
Amritosh, can you please repeat once again?
Yeah, of course. Don't worry. I will. Okay, so you understand this is upper tail problem, right?
Yes.
So now so far what did we do? Okay, let's say we assume there is a mu naught, that is 12 minutes. Okay, you have been given the standard def, so you can use the population standard def, so you can use z table. Now you know alpha. What is alpha? Alpha is 0.05. What it means is from here onwards, till positive infinity. If you were to take the area, it would come as 0.05. Now let's say mu s landed here. Okay, this is mu s. So fundamentally you got the z value, z of mu s. Now the issue is, how do you get this area? Because when you will use that table, it will give you area like this. Okay, from negative infinity till this point, right?
Yeah.
But you wanted this area, right?
Yes.
Sorry, this is not the correct good color. So how would I get this area? Basically, because the total area is
1 minus.
the total area is 1. So if someone gives me this area, this part, to get the upper area, I will just simply do whatever the value has been given so far. So whatever the value I got, let's say I got 0.9932. I did 1 minus 0.9932 as is the value correct, or should it have been 28?
0.068.
Sorry, my bad. So it is 0.9932, right?
Yeah,
Yes, 68. Sorry, my bad. Oh, yeah, I'm so sorry.
68.
Yeah. Now, based on the rule, what you would do, you will simply check, is it less than or greater than alpha, and you get p-value is less than alpha, and you reject h naught. Clear?
Okay.
And you can see whatever we are getting. So you can say there is sufficient statistical evidence to infer that Metro EMS is not meeting the response goal of 12 minutes. This is how it's looking. Okay, but you could have equally solved it through the critical value approach as well. Now with critical value approach, you just needed to get the z values. Now over there, we already knew z of mu of s is 2.47. What you needed to know is what is z alpha. Z alpha is, or z alpha was. So what is z alpha for a single tail? Is it correct or wrong? Okay, basically just get me this score, z alpha, which is alpha is 0.05, and it's a single tail problem. Okay, so what would be the value? Now there are multiple ways of doing this. So one way is basically when alpha is 0.05, then confidence is. So a simple trick I might have told you is you can also kind of do a reverse engineering of this chart. You can try to find where it is close to 95% and basically try to reverse engineer from there. Okay, so basically this is where you will get, this is the upper tail. So I told you to take the lower one, like 1.64, and we know basically it is 1.645. So z alpha happens to be this. So based on our rejection rule, if you understand, what was the rejection rule in critical value approach?
It's a point, not an area, right?
Exactly, it's a point on the real number line. Now you are comparing 2 points on real number line. So the rules are very simple. If in positive, if it is both of them are positive on the positive side, then z mu s. If it is greater than z alpha, then reject h naught. And that happens to be actually true here, because you can see g mu of s is 2.47, which is greater than g of alpha, which is 1.645. Because 2.47 is greater than 1.645, we can say there is sufficient statistical evidence to infer that Metro EMS is not meeting the response goal of 12 minutes.
I have a question. I think I'm a little bit confused just to by reading the example, and basically alpha is not confidence interval, right? Alpha is so 1 minus alpha is confidence. So alpha is I'm a little bit confused about alpha, but like how significance is and how
Basically,
we should.
You can call it region of accept. Okay, so let me call it. Alpha is basically acceptance criteria. Okay.
Okay.
So your confidence interval is nothing. CI is nothing but 1 minus alpha.
1 minus alpha, right? Okay. So alpha is acceptance criteria then. Okay.
Yeah.
So when you said 0.05 in the problem definition, so
Yeah,
that
so
is basically
it
acceptance
means,
criteria. Okay.
yeah. So they are meaning to say like CI should be 95% basically, or 0.095.
Oh, okay. Thank you. Yeah, it's a little confusing. It's opposite of two.
Yeah, you have to be careful with this one because it's not that straightforward as it looks. It's once you get hang of it, it's not very hard. But yeah, on the first reading, it does feels a bit confusing. I can understand this. So just with the practice, you will get better and you will understand when someone is increasing or decreasing alpha, what impact or how much it impacts the confidence interval. Okay. And okay, what would you have done in this two-tailed? Now, this is an example of single-tail. So in two-tail is pretty easy actually. In p-value approach, you get let's say the lower area. Now the assumption is it's symmetrical and balanced on both sides. So if I get the lower area correctly, let's say this is alpha and this is alpha. So now if I get this area correctly, I can just take it and just double it, right? Rather than calculating an upper area as well as a lower area, because it's symmetrical, whatever this area is, I can just take this area and just basically double the tail area. Okay, because this would be the same area, similar area in the positive direction as well. And thus the rejection rule remains the same. Did you get it? What just happened? The point is, if you calculate this area, you don't need to calculate this area separately as well. You can take this area and just do into 2. Okay, this will basically this will get both of these areas together, and then you can compare it against alpha and you can get the rejection rule as it is. So there is no change in rejection rule.
So in the previous example, yeah, if alpha was like 0.5, 0.25, yeah, on both sides, then we would find that it's 0.5, 0.05, yeah, and then the rest will be the same.
No, okay, alpha by basically what you are playing at is basically you are saying if it was alpha by 2, then you would have been dealing with something like this. So alpha basically becomes 0.05,
Yeah.
but remember, because alpha by 2, because it's a two-tail problem. Okay, so in two-tail problems, when you would try to solve this, what you will find is the test statistics would be such, or the way you will get is, let's say z value, you will get in plus and minus as well. So this will also be z of mu s, and this will be negative of z of mu s. So the idea is, and let's say this is alpha by 2 and this is alpha by 2 as well. So this is alpha by 2, from here onwards it is alpha by 2, and here onwards it is alpha by 2. Now the problem is, would you calculate both of the areas to kind of get the rejection reason, or sorry, because you have to get this area and sum them up, right? But cause it is well balanced already, it's a z curve, right? Z distribution. Rather just get this area, let's say, and just do a into 2, and whatever comes, that is the total p-value, and just do a simple comparison, that is p-value less than equal to alpha. If yes, then reject. Does it make sense? And of course, in intersection rule for critical value, you will have two rules and you will have to kind of try to solve for both of them. Okay, but it would be better if you just use p-value, it is much easier to solve. Okay, now solve this. Now this is a two-tailed problem because you cannot have a less toothpaste as well, and you cannot have also more toothpaste than a certain amount. So what we are trying to go is, for a production line for glow toothpaste is designed to fill tubes with mean weight of 6 ounces. Periodically, a sample of 30 tubes will be selected in order to check the filling process. Okay. Quality assurance procedure call for the continuation of filling process if the sample results are consistent with the assumption that mean filling weight for the population of toothpaste is 6 ounces. Otherwise, the the process has to be adjusted. Okay, so this is the problem, and try to solve this. So how do you solve this, guys? What are the steps?
First is hypothesis.
So what is the hypothesis?
So here it's saying, okay.
Null hypothesis is mu is equal to 6 ounces. Okay, you are assuming it is 6 ounces. So alternative hypothesis is it's not 6 ounces. Okay, plasma is not equal to 6 ounces. Now it's a double tail or two tail problem. Now level of significance given by the question is alpha is equal to 0.03. And what is the z value here? So if you were to use the maths, you will get like 6.1 minus 6. 6 ounces the mean filling weight remains the assumed one, of course. 0.2 divided by under root of 30. If you do this maths, you should get 2.74. Now, as you can see, this is positive, but the problem is two-tailed. Okay. So if you get some value for z of mu of s, if you get this area, you have to remember something similar will exist in this area as well. Because it's a double tail problem. So this is alpha by 2. This is alpha by 2. Actually not a good color. Maybe I should use this color. So how would you get the p-value approach? Again, you need to calculate one of them, of course. So for 2.74, you get the cumulative probability as 0.9969. You can refer to the table. Okay, 2.74. Okay, 74 is 9969. And then for getting the p-value exactly, it has to be done as 2 into 1 minus 0.9969. You understand why we are doing this step?
Yes.
Okay, because it's double tail. Okay, now the rejection rule remains the exact same. P-value 0.0062 is less than equal to alpha, that is 0.03, so we reject S naught. There is sufficient statistical evidence to infer that alternative hypothesis is true. That means the mean filling weight is not 6 ounces. Okay, so it will look something like this, guys. And similarly, by that chart, you can also maybe try to get z alpha by 2 value. So you can also solve through critical value approach. So in z alpha by 2, basically z alpha would be 0.0. It was 0.3, right? So 1.5. So for 0.015, you can go in the chart and look it up. Okay. So 0.015 is, if I'm not wrong, it should be 98.5. So again, you have to find 98.5 or something like this. So 98.75, 98. Yeah, 98.5. That happens to be 2.17. Yeah. Which you can see we have got here 2.17. So if you try to find the value of z 0.015, you would get as 2.17. And again, you just have to compare. So in the positive space, z of mu of s is 2.74, which is greater than z of alpha by 2. True. So reject the hypothesis, reject the null, reject the S naught. And similarly, you can do the other equation for the negative part as well. Is it clear for everyone what just happened?
Amardhan, small doubt in deciding this two-tailed test problem statement, because correct me if I'm wrong. Because the problem was very clear. Like it is, if it is exactly 6 ounce, then it's a perfectly it follows the null hypothesis.
Yes,
So
exactly. No,
why?
okay. So no, sorry. It's not exactly 6 ounces. There is an interval estimate. Okay. You have to understand this. Okay. So this is the whole idea of Gaussian that we are playing around with time and again. You have to kind of get used to this idea. Okay, so maybe actually I will use this figure itself. Okay.
So Z value is 1.99, 1.89.
Sorry.
This alpha by 2. Z
Alpha
alpha
by
by 2.
okay, hold on. Alpha by 2 is how much?
It's 0.97.
No, that was alpha. But if alpha is 0.3, then alpha by 2 is 0.015 because you are dealing in a two-tail problem.
Yeah, not that one. I was telling about alpha. Z alpha.
Again, we have to take Z alpha by 2, not Z alpha. Because the two-tail problem, right?
Critical value approach, sir.
Okay, I got it. Yeah, I've got the idea, Z alpha. So, okay, so you are saying, okay, what is your Z alpha by 2 value?
0.97.
0.97. Sorry, how can you get 0.97? You are saying Z alpha by 2 is 0.97. Okay, okay. What is alpha by 2 here? So what is your confidence interval? Or what is your confidence?
Okay, I was taking the alpha value,
Yeah,
not alpha by 2.
careful. Be very careful with this part, okay? This is where things go wrong. Yeah, because in that chart, it is the cumulative probability, that is the confidence that is basically given. So you cannot take alpha value over there. It has to be done 1 minus alpha first, or alpha by 2. Okay.
Okay.
Sorry about the previous. Okay, so the previous question that was we were dealing with is, okay, let's assume it is 6 ounces. Now the thing is, and you have to get this idea very correctly, it is always 6 ounce plus minus some error. And I hope you remember how to calculate the error.
Z alpha by 2.
Sorry, what was the formula for error?
Z alpha by 2 by mu by root n.
Not mu, it should be
Sigma by.
Wait, let me explain. Mu plus minus Z alpha by 2 into sigma of. So the idea is you can see the plus minus. So what we are saying is from Z mu minus or mu naught minus Z alpha by 2 to mu naught plus Z alpha by 2. This range is acceptable, okay? So the lower range will be somewhere here or somewhere, yeah, here and somewhere here. And this is the upper range. Now, if your test statistics fall outside of this range, then you reset H0, that somehow the mean filling weight is still 6 ounces. You understand what this 0.97 means? Or 97% confidence means what?
3% error.
Not okay, not exactly. Let's try to
This
revamp it.
97% will have 6 ounce of mean of 6 ounce.
Yeah, very good. You can say for 97% of the intervals, you would find the mean or the mu naught is between them. Okay, for 97% times, let's say if you take an optimal sample, you would find the 6 ounce or the mu naught somehow lies between it. So for 97% samples, you are very sure, yes, there are 3%, but that's what we are admitting, right? That yeah, in 3% we might not get it. But for 97%, I am very sure, or that's my confidence, that I will be correct. So with respect to your question, no, it is not exactly 6 ounce. Of course, it's a natural process, right? there would be some minor fluctuations. But how much fluctuation will not kind of de-standardize my product? That is what I have to know. Like if you have like all of a sudden you are delivering 6.5 ounces, which will basically spill over. You will not be able to close the top of the toothpaste. Okay. Or if it is too less, it is 5.5 ounces. People can come and see you altogether. So these kind of problems, as I told, there are a lot of medicines. Even you cannot have a very high dose, or you cannot have lower dose than the what you have printed over there. So the margin of error is very, very less over there. But still, there would be some margin of error anyways. But the idea is how much is acceptable to you. Okay.
Yeah, it's but still, is there any with respect to the problem statement? Yes, I can make it. Yes, it cannot be one-sided. It has to be either it can have a more or it can have a less filling.
No, but this is what it is. Okay. Yeah, you are correct. Of course, you are correct. That wait. So this is 6 ounces exactly.
But still, I'll finish my question, please. Okay. Is there any? You said the error intervals is been given. Is there any standard way, like for any given problem statement, can I understand what is the error intervals and differentiate the problems into one tail and the two tails? Maybe it's a very vague question.
No. It's actually a good question. Okay, first of all, as I again said, it will come by practice. You will have to kind of deal. Many times you have to know the context. Okay, how am I so confident that you can go both? You cannot go even in the upper direction, because I understand how a toothpaste tube works, right? If I put more toothpaste in the toothpaste tube, the cap will not close altogether. And of course, I cannot put less, otherwise the company will get sued, right? So many times this context comes from our knowledge of the real world as well. It is not like totally blind that yes, it is just a mathematical question. The context also comes from the idea of the world around us. So because I understand how toothpaste tube works, I can very easily tell you, yeah, it's a double tail problem. It cannot be a single tail, because it cannot be like, oh, you cannot give lower than 6 ounces, but upper is okay. No, you cannot get actually after a while upper as well, because you will not be able to close the cap over there. Okay, so it will spill over. So you have to understand, but many times if you have to get the idea like how, so I might have told you that basically the sign matters. Okay, what the question is really trying to specify you. If they are trying to pin you with an equality sign, and anything around equality is not okay, then it is definitely a double tail problem. So if you remember this part, where did it go? Yeah, this one. That if you can formulate your question in one of these three scenarios, you will come to know which tail you are really dealing with. But yes, some of the information comes from the information about the world around us. So we understand how the world works around us, and based on that also we have to kind of make sure that it is kind of posed, the correct hypothesis and the correct assumptions are posed properly. In a lot of examination or interview questions, it is usually given, or usually someone, if you ask them, they will tell you that yeah, we are dealing in one tail or we are dealing in two tail problem. But many times in real world, of course, there is no direct answer. So you have to get the knowledge, context knowledge, that what are we dealing here with.
Thank you.
And don't worry, it will take some time. Okay, you have to see like a lot of questions, and then only basically it will start to make sense, like when to use which. Okay, so don't get don't think like this is the only question that matters right now. Okay, there is a lot of the other ones that will also explain you and try to kind of give you some more information what you are trying to learn here. Okay. You can also